Long before telescopes pierced the heavens, ancient civilizations were already expert astronomers. Armed only with their naked eyes, careful observation, and remarkable patience, these early stargazers built sophisticated systems to understand the cosmos. Today we're exploring how our ancestors first began mapping the universe above them. Thousands of years ago, understanding the sky was not merely an intellectual pursuit, it was a matter of survival. Ancient peoples depended on accurate astronomical knowledge to know when to plant crops, when to expect floods, and when to prepare for changing seasons. The sky became both their clock and their calendar, and those who could read it best held tremendous power in their societies. The earliest systematic astronomical observations we know of come from Mesopotamia, the land between the Tigris and Euphrates rivers, which today encompasses parts of Iraq, Turkey, Syria, and Iran. This region, known as the Fertile Crescent, was the birthplace of civilization itself. Here the Sumerians, Babylonians, and Assyrians developed astronomy into something approaching a science. The Babylonian Revolution. The Babylonians stand out as perhaps the most sophisticated astronomers of the ancient world. Beginning before 1500 BCE, they kept meticulous records on clay tablets, tracking the movements of celestial bodies with extraordinary precision. These weren't casual observations. They were systematic, spanning centuries, and recorded in cuneiform script that has survived to our time. What made Babylonian astronomy revolutionary was its mathematical sophistication. They used a numerical system based on 60 rather than 10, which actually simplified calculations involving very large and very small numbers. This sexagesimal system is why we still divide hours into 60 minutes and circles into 360 degrees today. During the 8th and 7th centuries BCE, something remarkable happened. Babylonian astronomers began developing what some scholars call an early scientific method. They moved beyond simply recording observations and started using them to make predictions. They discovered that lunar eclipses followed a 19-year cycle, allowing them to forecast these dramatic events. This predictive approach marked a fundamental shift in human thinking about the universe. The Babylonians tracked the movements of all 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. They developed complex mathematical systems to predict planetary positions, creating what modern historians call System A and System B. These weren't simple charts. They were sophisticated calculation methods that accounted for the varying speeds of planets at different points in their orbits. Remarkably, this implied they had indirectly observed evidence for a heliocentric solar system, though they didn't interpret it that way. Their observations were so precise that centuries later, the Greek astronomer Hipparchus improved calculations of the moon's periods by comparing his own observations with those made by the Chaldeans, another name for Babylonian astronomers. The legacy of Babylonian astronomy spread to Greece, Persia, and eventually throughout the world. Egyptian astronomy, practical and divine. While the Babylonians excelled in mathematical astronomy, the Egyptians approached the heavens with different priorities. Their astronomical knowledge was deeply tied to practical concerns, particularly agriculture and religion. The Egyptians watched the skies carefully, but they were less interested in complex calculations than in using celestial events to organize their lives. The most important astronomical event for Egypt was the heliacal rising of Sirius, the moment when this bright star first becomes visible above the horizon just before sunrise. The appearance of Sirius coincided with the annual flooding of the Nile River, which deposited nutrient-rich silt across the land. Without these floods, Egypt would have been barren desert. With them, it became the breadbasket of the ancient Mediterranean world. Egyptian astronomer priests who could predict this flooding held immense power. They developed a solar calendar remarkably similar to our own, with 365 days divided into 12 months. They added 5 extra days at the end to keep pace with the solar year. This Egyptian calendar system would later influence the Julian and Gregorian calendars we use today. Egyptian astronomy also influenced their monumental architecture. The Great Pyramid at Giza contains shafts aligned with specific stars. One points toward where the star Thuban would have been 4,500 years ago. These weren't random choices. They reflected a cosmology where the sky and earth were intimately connected, where gods traveled across the heavens. The Egyptians divided the night sky into 36 decans, or star groups, which they used to mark the passage of time after sunset. They're also credited with dividing the day and night into 12 hours each, a system that originated from watching these star groups move across the sky. The Maya, masters of time. Across the ocean in Mesoamerica, an entirely independent astronomical tradition was developing. The Maya civilization, flourishing between around 500 BCE and the Spanish conquest, created one of the most sophisticated astronomical systems anywhere in the ancient world. What makes their achievements even more remarkable is that they developed completely independently, without any contact with Old World civilizations. The Maya were obsessed with time and cycles. They developed multiple calendar systems that ran simultaneously, including a 260-day ritual calendar and a 365-day solar calendar. But their crowning achievement was the long count calendar, which could track vast spans of time, thousands of years, with remarkable precision. Mayan astronomer priests tracked the movements of Venus with particular intensity. They recognized that Venus appeared as both a morning and evening star, and they calculated its cycles with extraordinary accuracy. This knowledge wasn't merely academic. The rising of Venus as a morning star was thought to determine the best time for warfare, and since Mesoamerican city-states were frequently at conflict, this astronomical information had immediate practical importance. The Maya built spectacular observatories like El Caracol at Chichen Itza, a round dome structure with a spiral staircase leading to viewing platforms. From these positions, astronomers tracked where celestial bodies rose and set against the horizon, using their pyramids as reference points to measure cyclical motions. Perhaps most impressively, the Maya could predict solar and lunar eclipses. One of the few surviving Mayan manuscripts, the Dresden Codex, contains detailed astronomical tables tracking eclipses and planetary movements. Spanish priests destroyed hundreds of similar codices in 1562, considering them sacrilegious, robbing us of untold astronomical knowledge. Astronomical architecture across all these civilizations, we see a common thread. astronomical knowledge embedded in stone. The Maya aligned their temples to the equinoxes and solstices. On the spring equinox at Chichen Itza, the setting sun creates a shadow on the Kukulkan pyramid that resembles a serpent descending the stairs, representing the feathered serpent god. The Egyptians oriented their pyramids with precision, and Babylonian ziggurats were themselves observatories. These weren't merely symbolic gestures. They were practical tools for tracking the heavens and maintaining accurate calendars across generations. The power of observation. What's most astonishing about ancient astronomy is what these civilizations achieved without optical aid. Every observation was made with the naked eye. Every calculation performed without modern mathematics or computers. The precision they achieved through pure dedication and systematic observation is humbling. These ancient astronomers discovered planetary cycles, predicted eclipses, tracked precession, and created calendars that kept societies functioning for centuries or millennia. They recognized that the universe operates according to predictable patterns, and they devoted enormous resources to understanding those patterns. Legacy and influence. The knowledge developed by these ancient civilizations didn't disappear. Babylonian astronomy influenced Greek philosophers, who transmitted it to Islamic scholars during the medieval period, who in turn preserved and expanded upon it before returning it to Europe. The Mayas' astronomical insights persisted in their descendants. With more than 7 million Maya people alive today, some still using traditional calendar systems. From ancient Babylon, we inherited the 360-degree circle, the division of time into hours and minutes, and the zodiac. From Egypt came the foundations of our calendar. From the Maya, we have sophisticated mathematical concepts, including the use of zero as a placeholder. As a conclusion, ancient astronomy reminds us that the human drive to understand the cosmos is not new. Thousands of years before space telescopes, before even simple optical instruments, our ancestors were already skilled astronomers. They watched the skies with patience and precision, recognizing patterns in the chaos, finding order in the movements of planets and stars. These early observers laid the groundwork for everything that followed: Greek astronomy, Islamic astronomy, and ultimately the scientific revolution that gave us modern astrophysics. When we look through a telescope today, we're continuing a tradition that began when someone, thousands of years ago, looked up at the night sky and decided to understand what they saw. That moment, lost in prehistory, marks the beginning of humanity's greatest intellectual adventure, our quest to comprehend the universe itself. If you enjoyed this journey through the terrifying beauty of space, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss what's coming next.